Our next speaker is Dr. Renee Carey. She has a PhD in psychology and is currently working as a postdoctoral research fellow in the School of Public Health at Curtin University. She was the project coordinator of a large-scale epidemiological survey investigating current occupational exposure to carcinogens, the Australian Work Exposure Study, AWES. Her current research looks at the future burden of occupational cancer resulting from current exposures. So her presentation, the Australian Work Exposure Study, Prevalence of Occupational Exposure to Carcinogens. Thank you, Renee.
Thanks, Pam. So today I'm going to talk to you about a study we conducted back in 2011 to 2012. It was known as the Australian Work Exposure Study, or AWES, and it looked at how many workers in Australia are currently exposed to occupational carcinogens at work. So what we know is that over 165 occupational carcinogens have been identified by the International Agency for Research on Cancer, or IARC. These include things that are relatively well known, diesel exhaust, which has got a lot of attention recently, asbestos, sun exposure, and also some more obscure chemicals, ethylene oxide and PCBs, for example. There's also 18 occupations or exposure circumstances that have been associated with an excess risk of cancer, and these include things like firefighting and painting. Exposure to occupational carcinogens is particularly concerning because unlike lifestyle exposures, such as diet and alcohol, they're commonly encountered involuntarily and often at greater magnitude than exposures in the general environment. They are also, thankfully, more likely to be amenable to risk reduction because we can implement controls in the workplace rather than attempting to change individual behaviour. So past studies of workplace exposures have contributed significantly to our understanding of carcinogens and cancer etiology, but significant knowledge gaps do still exist. We don't know the actual extent of exposure among workers. So prevalence information is important for a variety of reasons. Firstly, understanding prevalence allows us to understand the patterns of exposure across occupations, demographic factors, and is also useful for targeting prevention strategies. So if we know who's exposed, we know where to target our prevention efforts. Understanding prevalence is also necessary in order to understand the future burden of occupational cancer, so how many cancers might be caused in the future from current exposures. Unfortunately, there's not a lot of routinely collected data about the prevalence and extent of occupational exposure. Those studies that have investigated it have generally used imprecise measures of exposure, so they've used job title as a proxy for exposure, or they've focused specifically on specific exposures in high-risk industries, so they've discounted, or I guess, haven't focused on the exposures encountered by other workers. Large-scale surveys are needed. They have carried out large-scale surveys in countries such as the UK, Europe and New Zealand, and they generally use a similar methodology. So they interview workers about their work environment and collect information about categories of exposure, so dust, fumes, rather than focusing on specific agents. So an example of this is the news survey, which was conducted by Safe Work Australia in 2008. Interviewed 4,500 Australian workers and provided exposure to categories such as dusts and fumes, but it did target workers in predetermined priority industries. So there are a number of exposure assessment methods which we can use in large-scale studies of occupational exposure. These include job exposure matrices, or GEMs, which assign exposures based on a cross-tabulation of job titles against agents, and typically allocate the same exposures to everyone with the same job title. So this is meaning, so for example, that farmers would all get the same exposures even though there's considerable variability in the tasks that these people do. An alternative is self-report of exposures. Problem with this is the ability of respondents to accurately self-report their exposure varies greatly with the agent. We might be better, for example, at reporting exposure to the sun than to other chemical exposures. And participants may also be unaware of their exposures and generally don't have an objective standard against which to judge their own exposure. So a more objective method is expert assessment using occupational hygienists or other experts, and they look at an individual's job history and determine where their exposure was or what they're exposed to. This method is thought to be the gold standard for large-scale studies, but it's also been described as a black box, so it can be difficult to determine where the exposure actually, how that assessment was arrived at. This can be overcome by the use of an automated expert assessment system, and an example of that is OCIDEAS, which I'll talk about in a minute. Okay, so our study, AWS, used an automated expert assessment method to investigate the prevalence of current occupational exposure to carcinogens among Australian workers. AWS was a cross-sectional telephone survey of Australian workers aged between 18 and 65, all of whom were in current paid employment for at least an hour a week. Because, as I mentioned, there are a lot of carcinogens that we could have focused on, we chose to prioritise a list of 38 known carcinogens, which we thought were most relevant to working conditions in Australia. We used 3 criteria to prioritise these. So firstly, there had to be evidence of carcinogenic effects, and that was established by reference to IARC, and we included all Group 1 definite or Group 2A probable carcinogens. The second criteria was use in occupational circumstances, so we excluded agents like pharmaceutical agents and dietary agents, where the exposure is not primarily occupational. And finally, we looked at evidence of use in Australian industry. Our final list comprised of 38 carcinogens in 7 groups. We had combustion products such as diesel exhaust, dust such as asbestos and wood dust, metals, so chromium and lead, 4 sources of radiation including the sun, 19 industrial chemicals and 1 non-chemical agent, which was shift work. And the aim of AWS was to look at the prevalence of current exposure to this list of carcinogens. This diagram just quickly shows the interview process for our respondents. So we first asked for demographic information, then went through a quick screening questionnaire to determine whether the respondents' job fit into any of our predetermined categories of unexposed jobs. If they were unexposed, the interview was completed. Otherwise, they went on to provide more information about their job and then a job-specific module or JSM. So we had a team of occupational hygienists and cancer epidemiologists who developed JSMs for 57 different jobs or industries, things like driver, construction worker, painter, farmer. Each contained questions about the completion of job tasks, which were likely to lead to exposure to carcinogens, including information about the frequency of tasks, the task method, so for example, using a power sander or sanding by hand, and any protective measures used, so respiratory equipment, ventilation, gloves and other protective clothing. We also developed a generic JSM, which was used where we couldn't fit someone into one of our 57 JSMs. Answers to these JSMs were then used to provide exposure assessments via an automated, rule-based expert assessment method. That basically means that within a JSM, particular answers were linked to particular rules which triggered a particular exposure assessment. Each rule was formulated based on the literature, so we used exposure measurements where possible, and also the opinion of our occupational hygienists. So an example of a rule, if someone answered that they sand chipboard with a power sander and they don't use a respirator, this led to an assessment of wood dust exposure. Okay, so we ended up with an assessment as to the probability and level of exposure to each of our 38 carcinogens for each of our respondents. In terms of probability, we've got 3 categories, so possible, probable and none. And then once a probable exposure is assigned, we look to level. So we have high level exposure, which is defined as needing further control measures. Low level, where the exposure is present but we don't need any further control. And medium, which is a level between those, so qualitatively defined. And an unknown level, where we needed more information. Okay, so in our study we interviewed just under 5,000 Australian workers. Just over half were male and respondents were aged 18 to 65 as we wanted, with a mean age of 46. We looked at our respondents compared with the Australian population as a whole using the census, and our respondents were significantly older and more likely to be born in Australia, but similar in terms of gender, education and socioeconomic status. Overall, about 38% of our sample were exposed to at least one carcinogen. We found significant differences in exposure by occupational group. So 100% of our farmers, heavy vehicle drivers, plumbers, miners and painters were exposed to at least one carcinogen, and we did have smaller numbers in other groups, but we did have exposures across all of our occupational groups. So 9% of our office workers, for example, were at risk of being exposed. And they're exposed to agents such as diesel exhaust and benzene. So that indicates that they're still required to do some tasks involving driving, visiting construction sites, those kind of things. Most common exposures were solar radiation, so 22% exposed, diesel exhaust at 18%, and environmental tobacco smoke at 14%. And you can see the other common top 10 exposures there. In terms of demographics, we saw differences in terms of gender, age and education. Male workers were more likely to be exposed, those aged under 35, and those who had completed a trade certificate as their highest level of education. No difference in exposure between Australian-born and migrant workers. A little bit small, but in terms of occupation, we saw a significant difference in prevalence of exposure. So our trades workers were the most likely to be exposed, representing 32% of all exposed workers. Professionals, machinery operators and labourers were also more likely exposed than other workers. And the most common exposures among most groups were solar radiation and diesel exhaust, but we do see environmental tobacco smoke in our trades workers and shift work in our personal service workers. Okay, we also extrapolated our exposures to the Australian working population as a whole, and we found that around 2.7 million male workers and 0.9, just under a million female workers could be expected to be exposed to carcinogens at work, and that represents about 40% of the Australian workforce. Okay, so as well as giving an overall picture of the prevalence of exposure, AWS can provide us with an in-depth look at who in particular is exposed and what they're exposed to. We look at this in a variety of ways: occupation, industry, carcinogen, and also demographic subgroups. So just a few examples of that. Farmers, we looked at as an occupation. So we had a total of 166 farmers in our study, 76% male. All of them were exposed to at least one carcinogen, and on average they were exposed to 5 different carcinogens. Most prevalent exposures, as you'd expect, solar radiation, but also diesel exhaust and benzene. Exposure differences by gender, so male farmers were more likely to be exposed across all carcinogens, and also differences in terms of farm type. So combination farmers, those farming both crop and livestock, were exposed to more carcinogens on average. Another occupation we've looked at is road transport workers, truck drivers, taxi drivers, bus drivers, etc. In Australia, these workers account for around 2% of the working population, and the majority are male. So in Oz, we had 162 road transport workers, 88% male and most aged between 35 and 54. 98% were exposed to at least one carcinogen, and the most common exposures were diesel exhaust, solar radiation and environmental tobacco smoke. We did find some differences by occupation, so automobile drivers, so taxi drivers as an example, more likely exposed to tobacco smoke and to benzene from refuelling their vehicles, and heavy vehicle drivers more likely to be exposed to silica. Okay, so we can also look at industry. 603 people employed in the healthcare industry, most of them were female. 37% were exposed to at least one carcinogen, and the most common exposures there were shift work and ionising radiation. And we did also find exposure differences by gender within that industry, so more males than females were exposed, despite there being more females employed. Construction industry is another example, 459 employed, almost all male. Vast majority were exposed to at least one carcinogen, so 96% exposed, and the top exposures, the sun, tobacco smoke, silica and diesel. Okay, so we can also look in depth at particular carcinogens. So crystalline silica as an example, we've looked at how many people are exposed, who they are and what tasks they're doing to lead to that exposure. So overall 317 people were exposed to silica, about 6% of our respondents, and 165 of those at a high level, so needing further control measures. Males were much more likely to be exposed than females, so 10.5% of males compared to just over 1% of females. And also most commonly exposed occupations were miners and construction workers. In terms of the task they were doing when they were exposed, most frequently cutting, grinding, sanding concrete, mixing concrete, and working on mine sites near the crushers. Okay, so this just shows us the different pattern of exposure across a couple of occupations in terms of silica exposure. This is the top 5 occupations. And we can see most people across all occupations are exposed at a high level. Our miners, the first, and construction workers have a similar pattern of exposure. But when we look at the handy persons, so the 5th column there, none of those are exposed at a low level, and none of our plumbers are exposed at a medium level. Okay, so something else we've investigated is solar radiation. Over 1,000 respondents, or about 22%, were exposed to the sun at work, and over half of those at a high level. Again, we've got our males much more likely to be exposed, and our top occupations, farmers, painters, plumbers, drivers, and animal or horticultural workers, so that's gardeners are included in there. Looking at the pattern of exposure, we see our farmers are much more likely to be exposed at a high level, and painters are more likely to be exposed at a medium level, and we've got quite similar patterns of exposure amongst the other 3 groups there, plumbers, drivers, and animal horticultural workers. And we've got some information on protective measures, particularly related to sun exposure. We found that 95% of sun-exposed workers did use some form of sun protection, but only 9% were classified as fully protected, which we defined as using all 4 of these measures. Protective clothing was the most commonly used measure, followed by hats, sunscreen less so, and shade, which I guess is not terribly unexpected, was the least used sun protection method. Okay, so we can also look at exposures in certain subgroups of the population, including specific states. So Tasmania specifically, we interviewed 99 workers, 2% of the total study sample, which is roughly in line with the population of Tasmania compared to the rest of Australia. Half of those we interviewed were male, most aged between 35 and 54, and the majority born in Australia. We found that just under half of our Tasmanian respondents were exposed to at least one carcinogen, and that's significantly higher than the prevalence found in the national population. We haven't controlled for occupation here though, so it could be that there's different jobs or different job profiles here. Okay, when we look at the most common exposures, sun and diesel exhaust still the most prevalent. Compare that to Australia as a whole. We see more people are exposed to the sun, but slightly fewer to diesel exhaust. But also the distribution of exposures is different, so they all move around. Tobacco smoke moves down from 3rd down to 6th, and shift work moves up from 7th to 4th. We've also got a couple of changes, so chromium is now in the top 10, but artificial UV is not. In terms of demographics, so we have differences in terms of gender, male workers more likely to be exposed, Education, again, those who completed a trade certificate. Socioeconomic status, so lower socioeconomic, more likely exposed, and also remoteness, so outer regional, more likely exposed than inner regional, but no difference by age, country of birth, or language. In terms of occupation, again, our tradespeople were most likely exposed, and they were 23% of all exposed workers. But when we compare to Australia as a whole, we can see that exposures are much more evenly distributed in Tasmania across occupations, so most in the range of 10 to 15%, compared to Australia as a whole, which ranged from 3 to 32%. Okay, so just to summarise, our results indicate that there are still a large number of Australian workers who are exposed to carcinogens at work, and the prevalence of exposure is higher in Tasmanian workers than Australia as a whole, but again, small numbers, and we haven't controlled for occupation there. Exposures are across all occupational groups, even those that we traditionally think of as unexposed, but the proportion obviously varies across occupation. A couple of quick limitations. So the exposure assessments, they weren't self-report themselves, but they were based on self-report of tasks, so there could be some recall bias. Respondents might be answering how they think we want them to answer. And also we had a lower proportion of younger and migrant workers than the Australian population as a whole. Okay, so the methodology we've used was useful in indicating where control isn't adequate. So high levels of silica exposure among miners and construction workers points towards a need for better control in that area. We believe that using a population-based approach and also capturing exposures across a wide range of occupations are the particular strengths of this study. I'm currently working on using these results to estimate the lifetime risk of occupational cancer in Australia, so how many cancers may be caused from these exposures. And also looking at the potential success of various hypothetical intervention strategies so that we can see where our prevention efforts should best be targeted. So just to finish, I'd like to acknowledge the members of the Oz Cancer team as well as our funders. And thank you.
Thank you very much, Renee. Are there any questions?
There's not, but that's something that we can do with this modelling that we're doing now. Yeah, but cancer incidence is generally not reported by occupation.
Just curious about the shift work and the fact that it's coming up relatively high, and was just wondering whether you can point us to some more detail around that, I suppose.
Okay, so shift work we assessed in terms of whether they did a graveyard shift or an early morning shift, and we looked at 6 different metrics, so whether they were exposed to light at night, what their diet was like when they were on shift work, alcohol use, medication use, those kind of, phase shift, which is adjusting to the shift work. And so that exposure to shift work was a combination of those 6 different metrics. Yeah.
Any other questions? No? Well, thank you again, Renee, and you have very kindly caught us up with time as well, so well done.